Good morning, everyone. Darshan here. I'll be teaching physics, and today's topic is very important in terms of your life because it influences your life in aspects that you can't think about. And also, it's very important in terms of scoring. It doesn't matter which board you belong to. But this video is highly emphasized on CBSE grade 10 perspective. But it is going to be helpful no matter which board you belong to because end of the day physics is physics, the concept is concepts, right? The way they test and what they test might be different, but physics is physics. So the topic I am going to teach you, I will not tell you the topic directly. I'll rather give you some examples or real life situations. You think about, connect the dots, and let me know at which point you were able to guess the topic correctly, right? So the first keyword I would like to give with respect to this topic is, this topic that I am teaching right now is highly political. The topic is highly political. So what could be that topic of physics that would interest politics, and how is it related anyways? This is one way. And the topic I'll be teaching now is also related to economy. It's highly economical. Next, this topic is very important in terms of bodily functions, that is your biological functions is based off this topic. So how could physics be in biology? Think about it. And then other ways also includes in terms of warfare, it's important. Then the topic enables you to have a lot of fun here and there. That's it. So think about all these pointers, which is, it's political, it's economical, it is responsible for bodily functions, it is important in terms of warfare, and also it's fun. And one important aspect, there are many theories relate this topic towards origin of life itself. So what could be that topic of physics that would relate all these aspects? You think about all aspects, that could be energy, thermodynamics, light, whatever it is, but one topic that would fit in all these aspects, right? So think about it. Yeah. Now, obviously, it's a video, you can pause and think. So, I'm not going to pause right now. I'll get on with the lecture. I'll reveal that topic one by one, how it's related, right? So, thinking about political, think about the state Karnataka. Why Karnataka? Because the ruling party right now in Karnataka is Congress. And the major propaganda that led to the victory of Congress in the past election session was, as you rightly guessed, free electricity up to 200 units. Right now I live in Karnataka, and since my wife is from Karnataka, earlier before marriage I had to pay around 2000 to 3000 as an electricity bill. Right now post marriage my electricity bill has gone down to just 200 per month. It's a major propaganda which led to success of Congress in Karnataka. So I told the topic, which is, yeah, next one, talking about economical. How is it economical? I think you guys have to revisit back to this corona period where we had certain type of currency called as NFTs. It has no worth, it has no value right now, but back then it was traded for millions of worth of bitcoins, which we call it as non-fungible tokens. Even bitcoins, they don't have a physical form, they don't have a physical form, they just exist digitally. So what gave the basis for all those things? And even think about stock market. Obviously all of you would have seen these films like Lucky Bhaskar and the Scam 1992. How do you find the difference, or even the Wolf of Wall Street, how do you find it different in stock market trading back then and right now? How do you think it is much more easier and smoother? Is it possible without electricity? No, right? Even a kid of 16 years old like you can invest and take money. It doesn't mean that you have to wait till you have degree to start earning, right? Trading is made that simple. That's how a flow of economy is great. Next one, how is it related to the bodily function? Now, Just touch your heart. It's not here, it's not here, it's here. So touch your heart, and obviously you can hear the sound. I know if it was a classroom, we would have made fun telling that it's a lubbed up sound. That's fine. But think about it. How does your heart beat? Do you remind it to beat now and then? No, right? And I know it is called as involuntary action and all those things. But how does the heart beat? Are you clenching your heart? Like how you clench your lungs? Are you clenching your heart? No, right? Are you clenching your muscles like how you clench your heart? No, it's not possible. So how is the heart beating? The heart beats because of one specific node which is called as sinuatrial node. This sinuatrial node, the whole duty of this node is to give you shocks. It gives shocks to your heart, pulses to your heart, and this electrical pulses will make the heart to contract. That contract will push in the blood and the circulation is going to happen, right? That's why we have this certain thing called as pacemaker, which can be controlled by Wi-Fi and all those things, right? It's crazy how you can set the speed of someone's heartbeat using a mobile phone. This is pacemaker. Apart from that, what you see, how is this light signals processed by the brain? Because it's converted to electrical signals. How is it you're able to hear when I'm talking through this medium? Because the sound waves vibrate your eardrums, then that vibration is converted to electrical signals, which is transmitted to your brains, and the brain is reverse processing those signals, right? So all these touch, taste, all these impulses is happening because of minute electrical impulse changes in your network. Next one, warfare. How is it warfare? The future of warfare is cyber security, right? Now even the Indian Army is going to build up a whole regiment dedicated wholly for cyber security, but obviously it can't be under the same norms and conditions as a regular regiment. That's why it's taking more time. But cyber security regiment is not a far-fetched dream. It's going to happen. It's already in papers. I can sit in one place and literally launch a war on a country without leaving a trace. And how is it made possible? Because of electricity. Next one, how is it fun? It's fun. It's fun because let's imagine you have, okay, your siblings or cousins. I hope you like them. So you take them on a slide and imagine that slide is plastic or fabric based. Let me know if you have felt it. You bring them down the slide, and as they're sliding down the slide, you touch them, you'll get a shock. Right? Why is this happening? Because they have clothes. They might be wearing clothes which is made of polyester that might be rubbing against your uh, which is the slide, which is also non-conducting material. This will enable a transfer of charges, and this transfer of charge will charge the person. And when you touch your neutral body, you will get the shock. You can try this all the time, even in the school. You take up this material screen, you can take it up and rub it against your head, make your friend sit, and you touch your friend, they'll get a shock. Even when you're wearing your action shoes on Wednesdays or Fridays, when you wear the sports uniform, try rubbing against your cemented floor or the polyester ceramic floor, touch your friend, they'll get a shock. So it's also quite fun. Every time you take bath, come out, rub yourself in front of the mirror, you will get shocks here and there. Next, origin of life. Yeah, there are many theories that suggest that. There are many theories, like theory that suggests that humans were never, I mean, not humans, life never originated on the earth. We are from a different planet or different, all of things, where we come from a different asteroid that carry the first life from all those things. But we have many theories. One of the most prominently accepted theories is it used to be a very huge pond or pit of chemical fuels. Okay, so in these chemical fumes there was one specific lightning shock that created the first potassium based life form. That potassium based life form, the first unicellular organism which multiplied because of Charles Darwin's theory of evolution. Right now we are here. Okay, so there are theories that suggest that electricity is behind the origin of life. So think about electricity. Please don't give lame reasons like name applications like tube light, phone, charger. No, it goes beyond that. It even existed even before life could exist in the form of lightning. Okay, and it influences your life in aspects you can't think about. If this motivation is not enough for you to read electricity in this academic year, Electricity as a topic has more than 30 to 40% of weightage in your science paper. Electricity in the whole science paper. I think that motivation would do. And talking about your classes, we will have concept based questions, and then previous year questions and expected questions based on how the new norms are being framed by CBSE, right? So this grade 10 physics is going to be a piece of cake. It's not a big deal. Okay. So talking about electricity, all the other topics, what we will do, we'll start with your concept first, then go into the chapter, right? So this time what we will do, we will first start with your definition and then get into the concept. So talking about the definition of electricity. Talking about the definition of electricity. Electricity is defined as rate of flow of charges. It's quite simple, quite easy. The first topic of the academic year, please listen carefully. What is it called as? Rate of flow of charges. So there are three terms that you have to focus mainly on. One is rate, other one is flow, other one is charges. So we'll decipher what these terms mean and understand what is electricity. Talking about charges, charges is just a physical quantity that you know. Like how can you explain mass? Can you explain mass? No, we can't. We can just tell it's volume into density. We can't explain mass as mass what it means because mass just existed since the Big Bang. Nothing. We just know it's mass. You can't explain mass or define mass what it is. You can just quantity of substance. But what do you mean quantity of substance? No, you can't. Similarly, charge is a charge. That's it. A charge can have various properties based on which you can explain the properties of charge. But interestingly, charge itself can't be explained. Thinking about that, basically we all know there are two types of charges. That is, charges can be either positive or either negative. And there's a third type, which is not actually a type, which we call it as neutral. Neutral is when they don't carry any sort of charge. Either they don't carry any sort of charge or they have equal number of positives and equal number of negatives, right? An example for these charges include protons and electrons. We do have quarks, which are the constant material of protons and electrons, but we don't go that deep in CBSE as of now. We'll stop here. One is protons, other one would be electron. Other can also be cations and anions. These are the basic forms in which charges exist. So when these charges, either the protons, electrons, cations, anions move, flow, that produces currents. Clear? Now thinking about the structure of an atom, we will now decide which of these practically mostly can move, which of these cannot move. So let's imagine you think about copper. What are you, me, the universe, the whole thing made up of? Observable universe, the whole thing made up of? We are all made up of atoms. So talking about atoms, in the middle we have your nucleus. In the nucleus we have neutrons and protons, and around you have electrons. Whenever you write about a chemical reaction, would the protons move or the electrons move? Generally, yes, the electrons move because we're talking about energy exchange in terms of electron volts. If I try to remove this proton, it's literally creating a nuclear bomb, which you don't want to do right now. Okay, so what moves? Electrons move. So when these electrons go or slide from one atom to the other atom, that is what you call it as electricity. Clear? So now we have a clear idea regarding what these charges mean. It can be either protons, electrons, cations or anions. We'll see some of these properties. So when you have a positive and positive, they will ripple. Similarly, even negative and negative would ripple. And which would attract? The opposite ones will attract. And why do they attract or why do they repel? Because they have an area around which where you can feel their force, which you call it as field, field, and that is made up of lines which are pointed outwards for positive charge, made up of lines which are pointed inwards for negative charge. So when you are in this field, you will experience the force. And talking about this field, you don't imagine a 2D diagram. Imagine you take up a tennis ball, the green tennis ball. You poke your mom's needles. Let's take up moms or dads. I can't be stereotypical. Take some needles, like maybe hundreds of needles. Poke everywhere around the tennis ball. How will it look? It will be like a round porcupine hedgehog, right? That is how a charge will look. A ball with hundreds of needles around. And if the needles are all pointed outwards, it's a positive charge. If the needles are all pointed inwards, it's called as negative charge. If you want to experience a force of attraction or repulsion, you must be in one of these charges. That's it. So let's have a small demonstration here. Let's imagine I'm an atom and I have 4 protons and 4 electrons. So since there are 4 protons and 4 electrons, right now my charge is neutral, right? Let's say I have my friend. I go and steal one of his electrons. Now I got 5 electrons and I got only 4 protons. Since 4 protons is there, 4 electrons will match up. So how much is left over? One of my electron is left over extra. So I became a negative charge. Since I stole one electron from my friend, he became a positive charge. So you tell a body is positive or negative in terms of electrons, whether they have more number of electrons, whether they have less number of electrons, right? So more deeper than this, like what is conduction and what is induction and condensation of charge, all these will be dealing in your 12th grade when you have your first chapter, right? As of now, this will be the introduction about what you understand about a basic charge. So what is charge? We have 2 types of charge, positive and negative. Positive means either protons or cations, negative electrons or anions. Typically protons can't move, only the electrons would move. They will have either repulsion or attraction. For positive charge, the field lines are outwards. For negative charge, the field lines are inwards. Now we'll get into the technical part. Whenever you go to a shop, you don't, it's summer, so you don't get liters of mangoes, right? Or you don't get meters of mangoes, right? What do you get? You get kilograms of mangoes, because the right unit must be used for the right quantity. Similarly, when you talk about charge, you can't tell 5 kilograms of charge or 5 liters of charge. You tell it using coulomb. You tell it as coulomb. The SI unit of charge is called as coulomb because this person gave us Coulomb's law, which is one of the basic understanding about charge, which opened up a wider perspective about the study of modern day quantum mechanics. Clear? So talking about charge, the SI unit of charge is coulomb. Next, the way you represent charge is by Q, that is your symbol. So let me tell that you are a positive charge. You are what charge? Positive charge. Let's say you are a positive 2 charge. So how will I tell a positive 2 charge? Your charge is positive 2 coulombs. So C is your unit and Q is your charge. Let's say I have an object here and I have to tell this object has a charge of 3. How will I tell? Charge is equal to 3 coulomb. Is that clear? So Q stands for the symbol and C stands for the units. I hope it's clear now. Now let's get back into the atomic structure and atomic level. How much basically is 1 coulomb? How much basically is 1 coulomb? We'll try to understand that. So talking about an electron, the size of an electron is really small. You know it. We can't even see it visually. So that's how small an electron is. So when the electron size is so small, can it have a very huge charge? No, right? Even the charge has to be very small. So the charge of electron is a very small number, which is given as 1.6 into 10 to the power minus 19 coulomb. Charge of an electron is a very small number, which is given as 1.6 into 10 to the power minus 19 coulomb. How small is it? How small? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 16 coulomb. It's a big number, very small number. It's a very small number, which is 0.18016 coulomb, right? So charge of an electron is very small and charge of electron is equal to charge of a proton. The symbol are same, you just represent negative for electron and you don't represent anything for a proton, but the symbol is E and E only. Clear? And charge of proton is equal to charge of an electron. The masses are not same. Proton is very much heavier, but charge wise electron and proton have the same charge, which is very small. Now if this was the case, let's say Darshan is here, I'm round, let's say Darshan is here, and I'm telling that Darshan's charge is equals to 1 coulomb. I'm telling that my charge is equals to 1 coulomb. If my charge is equal to 1 coulomb, how much electron should I lose? If my charge is equal to 1 coulomb, how much electrons should I lose? It can either be put up as how much electron I should lose or how much protons do I have more than the electron. Got the logic? It's either how much electrons I lose or how much protons I have more when compared to the electrons. So thinking this logic, give me the answer. Think about it. What mathematical equation can be created in this aspect? So here, if I take up 1 paise notes, if I take up 1 paise notes, if I equal 1 paise notes, I need 100 of them to get 1 rupee. 1 paise coin or note, I need 100 of them to get how many rupees? 1 rupee. This 1 rupee is your 1 coulomb, right? And this 1 paise is what we have it as 1.6 into 10 to the power minus 19 coulomb. So how much I require is this value, I keep it as n, that I don't know. So same logic, try to correlate 1 paise, I need hundreds of them to produce 1 rupee. Same logic, I want 1 coulomb of charge and the value for each electron or each proton is just 1.6 in 10 to the power minus 19. So how much like that would I require to get this 1 coulomb of charge? Apply this logic and tell me whether it will be a big number or a small number. It will be a big number or a small number. It's like, you have mustard seeds of 1 gram. How many mustard seeds of 1 gram do you require to get 1 kilogram? You need thousands of them, right? 1000 mustard seeds of 1 gram is need to produce 1 kilogram. Same logic. So if I apply that logic, the number of electrons I should lose or number of protons I have in extra, it's a huge number. It's a very huge number. Trust me, it's not even crores or it's not even billions. It's a very huge number, and that number is 6, 2, 5, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. I require these many number. Why is this number very huge? This number is very huge because my charge of each electron is very small. That is why this number is a very huge number. Clear? How do I get this number? I just equated that my charge is equal to 1 coulomb, which is equal to 1.6 into 10 to the power minus 19 into n. And what would n be equal to? N is equal to 1 divided by 1.6 into 10 to the power minus 19. And if you solve this part, take your calci out, please solve it. You will get the value as 6.25 into 10 to the power 18. So value for n is a very huge value, which is 6.25 into 10 to the power 18. That value is very huge because it has to compensate with your e value. So only then you get the answer as 1. Now, based on this, we have a formula for charge, which is the first formula for electricity, which is called as Q is equals to N into E, where E value is always fixed, which is 1.6 into 10 to the power minus 19 coulomb. And N value for 1 coulomb is fixed, which is 6.25 into 10 to the power 18. So this must be literally your mantra running throughout your academic year in your head. Even by chance I come to your bed, wake you up from sleep and ask you what is the value, you should tell 1.6 into 10 to the power minus 19 and 6.25 into 10 to the power 18. Right? Now, if you could correlate this with respect to conductors and insulators, you will get a very huge insight. My earlier statement was you, me, Everything in this observable universe is made up of atoms. So basically we all have electrons. So since we already have electrons and protons, when you pass current, current has to go through, right? Then why current is not passing in certain materials and why current is passing in certain materials? What makes the difference here? This number makes the difference. Which number? This number. Achieving this number, achieving the free flow of these many number is very hard in terms of materials that you categorize as insulators. It's not that they don't have electrons or protons, but achieving these number, which achieving this huge number in such a small space which can enable a flow is not easy. Obviously we have other factors, but this is one of your major key criteria, right? That is why if you think deeper, there is no such thing as insulators or conductors if your voltage is high enough. Example, air. Air is a very good insulator. If I just put my hand inside the socket right now, I will not get a shock. I mean, not literally inside, near the socket right now, I will not get a shock. Because air is not a conductor. Electricity cannot flow from air to my fingers. Air is an insulator. But what happens during lightning shocks? The lightning literally strikes all the way from the clouds to the ground or to the tree or the building, right? How is it happening there? Is it because of rain? No, rain is one of the criteria to help it out, but it is breaking the barrier of air being an insulator. How is it possible? Because of thousands of volts. So if your voltage is high enough, even insulators can become conductors, because end of the day we are all made up of atoms, which is made up of protons, electrons and neutrons, right? But those exceptional cases we don't deal CBSE right now. We are just dealing about just basic insulators, conductors. Example, aluminum, silver, copper are good conductors, and woods, plastic, all glass, all these considered as insulators. I hope it is clear. Next one key question here. If you think in terms of conductors, silver is the best conducting material in compared to copper and aluminum. But why don't we use silver? It's a very basic question though, but it was asked in CBSE quite a lot of time. It is because it is not easy to manage the cost. Silver is quite costly. That's why we don't use silver, but we go for copper and aluminum. Right. Now, let's get back into the major topic, which is electricity. Now, the whole story was about charges. We'll go to the other two terms. So, under charges, we saw protons, cations, electrons, anions. Repulsion, attraction, it is fine. Then we saw electron values 1.6 10 minus 19 coulomb. Since this number is fixed and very small, we need to have 6.25 into 10 to the power 18 number of electrons. Just call myself as 1 coulomb of negative charge. Or if I have more protons, I should call myself as 1 coulomb of positive charge, right? So the next term that comes into play would be the term flow. What do you mean by the term flow? And where else do you have the term flow in terms of general English scenario? So you can use the term in terms of current scenario, today's scenario, right? Apart from this, there is one major area where you use the term current. Think about it. Think about it. You can pause and think. I will not think right. I will not give you the time to pause right now. The next major area where you can use the term current in English would be for river current. Do you remember? We used to read a lot of news that people died, or there was a shipwreck and all those things because the river current increased unprecedentedly, right? So what is this river current? Does the river carry current? No. It is how fast the river is flowing. If the current is high, that means the river is moving faster. So the term current is associated to flow. That is why the chapter is called as current electricity, because we're dealing about electrons which are flowing. They're not jumping from one atom to the other. As I told earlier in the diagram before, they flow from the external orbit of one atom to the other atom. Clear? That is why we have the term flow in the definition. Next, what we have in the term is rates. Always remember, doesn't matter chemistry or physics, for that sake, any scientific subject, the term rate comes, it means one specific quantity of physics. For example, if I give you 13 inches pizza of 8 slices and I ask you after you finish eating and I ask you at what rate you had your pizzas, what am I asking here? Am I asking for the cost? No, right? I'm asking at what time you completed it, or how fast you completed it, and how long you took for it. So the term rate is applied for time. So whenever you have the term rate, you by default should fix up, it means time. So combining, putting these together in a single picture, I can write electricity in the form of an equation. I can write the whole of electricity in the form of an equation, and that equation would be current electricity is rate, that's why I have time, of flow of charges. So current is equal to charges by time, because rate of flow of charges is called as current. And just like how we had for symbol for coulombs around, we have symbol for current as I. I is equal to symbol for charge is Q, symbol for time is T. That's it. And to be more specific about the definition, we also have other terms like rate of flow of charges, or charges flowing per second in the cross section area of the wire. We deal about a cylindrical wire most of the time. So if it's the cross section, it will be a circle. If you take up a cross section of a rectangular wire, it will be a rectangle or cuboidal wire. If you take up a wire which is having three sides, it will be triangle. So whatever charges that flow in that specific shape in that area is called as current. It's an intricate, detailed explanation that we don't have to do it right now. We'll do it in other videos when we deal about J on NEET or your 12th syllabus. Clear? Where we deal about drift velocity and how the things go and all those things. So talking about current, the SI unit of current is ampere. SI unit of charges, which you already know, it is coulomb. And SI unit of time, it's very new, you know it is seconds. So SI unit of current is ampere, SI unit of charges is coulomb, SI unit of time is seconds. How do you define 1 ampere then? 1 ampere can be written as 1 coulomb by 1 second. 1 ampere can be written as 1 coulomb by 1 second. That means that if I have a piece of wire, again, which is made up of what? Lot of atoms, billions and billions of them. I take up exactly 1 coulomb of charge. Again, this 1 coulomb of charge has how many protons or how many electrons? 6.25 into 10 to the power 18. It's just a hidden data. These many electrons or protons, I take them, I'm not defining plus or minus. So 1 coulomb of charge from this point A travels all the way to point B in certain time, which is 1 second. In this scenario, where I carry 1 coulomb of charge from point A to point B in 1 second, the current going from point A to point B is given as 1 ampere, because 1 ampere is defined as 1 coulomb by 1 second. That's it. And the device that you use to measure current is a meter. Ampere is SI unit, right? So a meter. Meter is for measuring. So the device is a meter. And I'll give you two more terms. The term that you will not have a clarity about right now, but trust me, over the videos, when we deal about those topics, you'll have a clarity. They are always connected in series. Draw a very big question mark on why. Next one, the resistance. The resistance is really low, which is almost equal to 0. Here also put a very question mark, why, and mark this page as a bookmark. We'll come back to these points when we deal about resistances, when we deal about series. Okay, and then I want you guys to quickly solve a question based on this. Let me carry around sample question number 1. Let me carry around 10 coulombs of charge for a time interval of 2 seconds. So what is my current? very noob question, you guys know it, which is I is equal to Q by T, which is going to be 10 by 2. Answer is given as 5 amperes. As simple as that. Charge by time will give you current. So what are other type of questions you can expect from this point? I don't want to pressurize you guys telling about all the expected questions or competency based questions that you can frame, because my aim right now is to make you comfortable with physics, electricity, and make the concept familiarize with you in terms of thoughts. Once that building block is achieved, you don't need my help to fill in the other blocks. It's very easy for you to go. So the basic, let's build it fundamentally strong. Talking about your sample question number 2, I gave you charges and time, right? So this time I'll give you the current. Current is equals to 5 amps, which is flowing for around, let's say, 1 minute. What is the charges that flows the wire? So what are the major red flag in this question? The major red flag in this question is the unit. The unit is in minutes, but what should the unit be in? It must be in seconds. So convert minutes to seconds. So it can be given as 60 seconds. So I is equal to Q by T. So Q is equals to IT, which is 5 ampere into 60 seconds, which is 300 coulombs. 300 coulombs of charge has to go for 60 seconds to produce 5 amps of current, and by default you unlock the new formula. What is it? It's like level increment. So you got Q is equal to Ne as the old formula, and you got one more formula as what? I into T, which also can be used. So here we learn two things right now. Whenever you have time in minutes, please convert to seconds. And next thing is Q is not only equal to N into E, it can also be written as I into T. So how will you correlate this concept with respect to N into E concepts using that formula? So based on that, we will see one question and we are good to go for today. Next is your sample question number 3. In your sample question number 3, before we start with sample question number 3, I want you to familiarize with certain terms. Whenever you have 10 to the power minus 3, it's called as milli and the symbol is small m. Whenever we have 10 to the power minus 6, it's called as micro and the symbol is mu. And when you have 10 to the power 3, it is called as kilo and sample is k, symbol is k. And when you have 10 to the power plus 6, it's called as mega usually, and symbol is capital M. Major confusion happens between micro, milli and mega, where you get confused with 6, minus 6 and minus 3. So this, you please make a note of it. You will be using this in electricity a lot, because as I told, getting that number of 6.25 10 to the power 18 is a very huge number to find. So if you take up just 10 coulombs of positive charge in your right hand and 10 coulombs of another positive charge in your left hand, will they attract or will they repel? They will repel. Obviously they will repel because they both are positive. But that is not the point here. If you have these two charges in your hand, try to pull them together. You will literally have the repulsive force equal to lifting at least a 4 to 5 story building. Or we could even compare to Taj Mahal. It's written in one of the famous books by one of my favorite professors, Dr. Walter Lewin. He had specified this even more beautifully. So if you have 10 coulombs of positive charge in the right hand and 10 coulombs of positive charge in the left hand, try to push them together, you will experience the repulsive force. That repulsive force is strong enough to even carry Taj Mahal. So that is the magnitude of force we are dealing. So usually, practically speaking, the magnitude of forces that can existingly deal about would be in terms of micros, millis. Clear? So you'll be having questions based on this in MCQs and 1 or 2 marks max, not beyond that. Clear? But that also is very important because writing physics only 25 marks. For 25 marks, 1 or 2 marks is very huge, and if you're aiming for centum, that's even more important. Clear? So from the first part, what I've seen until now, which is I is equal to Q by T and ammeter and all those things, you can expect maximum of 2 marks. In that, you can expect either these questions from the MCQ or this one major question I'll be doing right now. It can be expected in the form of a 2 marker. That is sample question number 3. Now, a current of 2 amps is flowing for 2 minutes. How much electrons are passing. How much electrons are passing in the wire? Always remember, if they talk about charge, if they ask how much is the charge, you have to find Q. If they talk about how much electrons or how much protons, you have to find N. Here I am asking for number of electrons. So how will you find the answer? Try to correlate. Here, so basically I want N, so I'll write Q is equal to IT, which is also equal to N into E. I don't have Q, but have I and T. E, nobody has to tell me because I know the E value, which is 1.6 10 to the power minus 19. So only unknown variable here is N. I can substitute and find the answer. So first what I can do is find the value for Q. So Q will be written as, what is the major red flag here as well? You have time in minutes, convert to seconds, you got 120 seconds. So charge is given as current into time, which is 2 amperes into 120 seconds, which is 240 coulomb. This is your charge. Now equate this with respect to N into E. So 240 coulombs is equal to N into how much? 1.6 into 10 to the power minus 19 coulomb, which is 240 divided by 16 into 10 to the power minus 20 is equal to N. Why? 1.6 I made into 16 because I'm very poor in terms of decimals. So I convert to fractions to solve. So it's 16 into 10 to the power minus 19. I mean 20 because one more zero got added up over there. And the whole thing came down as division. So we just have to solve 240 and 16 right now. This will go up automatically. It becomes 10 to the power plus 20. So I'll take 4 times. 4 4s are 16. And this will be 4 6 are 24 and 0. 4 1s are and 4 15s are. So I got 15 into 10 to the power plus 20 as N. So what do you mean by this right now? If I have a wire, in this wire, if 2 amps of current is passing for how long? For 120 seconds. How much electrons are passing? How much electrons are passing? How much electrons are passing? The number of electrons passing is, it's a very huge number, which is 15 into 10 to the power 20. These many number of electrons have to pass just for me to have how much? 2 amps of current. Okay, so that's it about current electricity for today. I have two major follow-up works for you guys. One thing to go through your NCERT textbook, try to solve the relevant questions based on this topic, especially your in-text question and your example question. Next, one major follow-up is with respect to using AI to follow up with what comes up next. Right now we learned about current, which is flow of charges. That's fine. But my question is, how do you make them flow? We know the charges flow, it produces current. Can you make them flow by blowing it? Can you take a piece of wire, blow from one end, expect it to go to the other end? Can you take a piece of wire, hold it upside down, and grab it to pull it down? It's not possible, right? Then how do you make the charges flow to produce current? This is my first question that you will be finding it. Next question is, I told flow of current in terms of electrons, right? But technically speaking, we conventionally follow flow of current as flow of protons. But protons never flow. But why do we take it as flow of protons? So this question and your previous question are related and conventionally more related to a scientist. So think about these two questions. Try using AI or any other tools, whatever you can, refer to your seniors if possible, get back with an answer, and we'll start with your next topic with these questions as the fundamentals, which is how do you make the charges flow? And next is generally the current is taken as flow of protons, which is not possible because we know electrons only is flowing, but why do we take it in a wrong manner? Okay, find the answer and come. We'll follow up with the next class tomorrow. Thank you for patience. Thank you for watching. See you soon.